Continuation pa rin ito class ng discussion natin sa application of integrals. So, but this time, ang itatakol natin is the center of mass. Sa center of mass class, suppose a number of masses are located at various points in the xy plane. Imagine that the masses are supported by a weightless tray. So halimbawa class, may tray tayo or weightless tray tayo supported by a knife edge sharp nail. So ibig sabihin yung weightless tray na yun is nakasupport yung or may supported na knife edge sharp nail siya. So, ibig sabihin nun, malalaman natin na yun yung center of mass ng tray na yun if yung weightless tray na yun is balanced siya. Okay, ibig sabihin na this kanyang kulog kasi na babalancens kanyan using the knife edge sharp nail. Ibarat buo, labas kanyan balance, ibig sabihin na kulog sa tray, na which means hindi yun yung center of mass ng tray na yun. Also, one knows from experience that a smaller child can balance with a bigger child on a seesaw by sitting further from the fulcrum or pivot point rather. So, di ba, nung bata pa tayo or sa elementary days natin class, di ba isa to sa mga laro natin, itong seesaw na to. So, kahit na yung umupo sa seesaw na yan is mabigat at saka hindi mabigat, pwede pa rin mabalance. Okay. The tendency for a mass to produce irritation about a fixed point is proportional not only to the magnitude of the mass, but also to the distance between the mass and the fixed point. This tendency for the mass M to produce a rotation about a fixed point A sub O on the x-axis is measured by the quantity called the moment of M about A sub O. It is denoted by M sub O, or M sub O is equal to M times X minus F sub O, A sub O rather. The number X minus A, etong X minus A dito, or X minus X sub O is called the moment arm or the lever arm, which is positive or negative depending on whether M is to the right or left of F sub O. Positive moment arms produce positive moments and clockwise Clockwise rotations, consequently, negative moment arms produce negative moments and counterclockwise rotation. So, katulad lang sa orasan, pag counterclockwise, ibig sabihin nun, negative moments arms produce negative moments. And then, pag positive moments arm naman, produce positive moments if yung rotation is clockwise rotation. Consider a line and a system of 4-point masses m sub 1, m sub 2, m sub 3, and m sub 4 located in the x-axis. Okay, so please refer in this figure. Okay, let's say ito yung m sub 3 natin, m sub 4, m sub 1, and m sub 2. So m sub 1 located on the point x-axis sa 2, and then si 2 m sub 2 naman is sa 4. Si m sub 4 is dito sa 1, si m sub 3 is sa negative 4. Unless otherwise indicated, masses are in kilograms or grams and distances are in meters or in centimeters. Let x sub 1, x sub 2, x sub 3, and x sub 4 be the distances of the masses m sub 1, m sub 2, m sub 3, and m sub 4 from this origin O, where x sub I is greater than 0 if m sub I is located on the right side of the origin O, diba? And then yung x sub I naman natin is less than 0, which means negative numbers. Ibarat buo sa mga masses tano na located sa negative side or in the left side of the origin. We define the first moment of inertia of m sub I with respect to the origin O as the product of m sub I times x sub I. So, ibig sabihin, mass times the distance. Also, if we locate the center of mass of the system, x bar, it is found at the point where the system will balance when supported with a sharp-pointed knife edge or sharp nail. Okay, so malalaman natin na balance na siya or yung center of mass na yun is found at point where the system will balance when supported with a sharp-pointed knife edge or sharp nail. The center of mass or centroid x bar is the equilibrium point of the system of masses where the total mass m sub t or total mass equals to m sub 1 plus m sub 2 plus m sub 3 plus m sub 4 can be positioned to balance the system. That is, the moment of inertia of m sub t or total mass is equal to the sum of the moments of the system. Okay, so take note class or recall natin class yung formula ng midpoint formula. X bar is equal to x sub 1 plus x sub 2 over 2, and then y bar is equal to y sub 1 plus y sub 2 over 2. So, kung x bar yung ginamit sa x-axis doon sa midpoint, ang gagamitin din natin dito sa center of mass kung x is x bar din. Kung y naman, y bar. Total mass times the distance x bar is equal to m sub 1 times x sub 1 plus m sub 2 x sub 2 plus m sub 3 multiplied by x sub 3 plus m sub 4 times x sub 4, or ang x bar, solving for the x bar, or that is this one of the center of mass, ito yung magiging x bar natin. Okay, in general class, the center of mass of a system of point masses m sub 1 to m sub n located on a line at x sub 1 to x sub n is given by this formula. So, x bar is just equal to the summation of m sub I, or ibig sabihin nun yung total mass multiplied by the total distances plus divided by the total mass where I is ranges from 1 to n. Okay, so ito yung formula ng isa sa formula ng center of mass natin. For example, find the center of mass of the system of point masses on the x-axis. Ang given na masses natin is m sub 1 equals 4, m sub 2 is equal to 2, m sub 3 is equal to 1, and m sub 4 equals to 3. So remember, yung masses natin dito is in terms of kilogram or gram. So, using the formula 1, yung sa previous slide, for the center of mass x bar, okay, so ang x bar natin is magiging m, di ba ito yung formula, m sub 1, or the mass 1 times the distance 1 plus mass 2 times the distance 2 plus mass 3 times distance 3 plus mass 4 times the distance 4. So, itong masses natin class is it is located at x sub 1. Si m sub 1, located siya kay x sub 1 equals to 2. Si m sub 2 naman, ang partner niya is si x sub 2. Si m sub 3 is si x sub 3. M sub 3 is si x sub 4. So, i-times nyo lang to. Times nyo lang din yan. Times, and then i-add nyo. Divided by the sum of the masses. Okay. Of the system. So, divided by m sub 1 plus m sub 2 plus m sub 3. So, ang m sub 1 natin class is 4. Ang x sub 1 is 2. So, 4 times 2, ito siya. 2 times 4 is ito siya. 1 times negative 4 is ito sa third term. And then 3 times 1 is ito siya. And then, sa denominator natin is yung sum ng masses natin. We have 4 plus 2 plus 1 plus 3. Or this is equal to 1.5. So, ibig sabihin, ang center of mass natin class is andito. X bar is here between 1 and 2. So, nandito siya. So, magiging balance yung weightless tray natin, for instance, if nandito yung if it is supported by a sharp nail, knife edge, or a sharp nail. So, let's say, imagine ninyo itong x-axis, yan yung weightless tray. Tapos, ito yung supported na knife edge rather. Okay, that is, the equilibrium point is at x bar equals to 1.5. The next example will show that the center of mass of a system is independent of the choice of the reference point O. Find the center of mass of system of point masses on the x-axis. So, the same pa rin ng masses doon sa first example natin. Located at x sub 1 equals to 3. So, magkaiba na sila ng distances. Okay, located at 3. X sub 1 is 3, and then x sub 2 is 5, x sub 3 is negative 3, x sub 4 is 2. So, ibig sabihin nun, it doesn't matter kung mabago yung distance ng given natin na masses, kahit the same pa rin yung given na mass natin. So, this time, sa m sub 1, it is located at x sub 1 equals 3. Sa m sub 2 naman is located at x sub 2 equals 5. M sub 3 is located at x sub equals negative 3. And then m sub 4 is located at x sub 4 equals to 2. Note that this is the same of masses in previous example, with reference point O shifted 1 unit to the right. Okay. So, this is the figure 5.2.4. Okay, so, since nabago yung location nila, which means mababago din yung center of mass natin. So, using the Formula 1 class, just multiply the mass and then their location. So, m sub 1 times x sub 1 up to m sub 4 times x sub 4 divided by the sum of the masses. So, we have si 4, galing yan yung doon kay m sub 1. Substitute nyo lang ha. And then si 3 is kay x sub 1 yan. The same with m sub 2 to m sub 4. So, we get 25 over 10, or that is 2.5. So, this time, dito na yung center of mass natin. Note that the center of mass x bar is equals to 2.5 is located at the same point relative to the given system of point masses. So, kanina kasi dito, di ba? So, parehas pa rin. So, relative pa rin sila. Now, we consider system of masses m sub I in the plane located at x sub I and y sub I, at the point x sub I and y sub I. Here, the moment of inertia at m sub I with respect to the x-axis is the product m sub I times x sub I pa rin. And the moment of inertia of m sub I with respect to the y-axis is magiging m sub I and y sub I. Kung with respect to x-axis, yung x yung gagamitin natin, multiplied by the mass of this system. And then, kung with respect to y-axis naman, yung y location niya in terms of, with respect to y-axis rather. Therefore, the center of mass is magiging x bar and y bar. So, yung na-mention ko nga kanina, the same lang to doon sa midpoint formula. Center or midpoint is just the same, di ba? Okay. Look of n masses located at points x sub I and y sub I is given by this formulas. Kung x bar, that is the summation of the masses times the product of the mass and the location. divided by the sum of the masses. And then y bar naman, the same lang din. X yung ginamit with respect to x, and then y naman yung gagamitin with respect to y. For example, find the center of mass of the system of the point masses m sub 1 equals to 3, m sub 2 equals to 2, and m sub 3 equals to 5. So kung gagraph, ipa-plot natin to sa xy plane natin located in the plane at si x sub 1 is and y sub 1 first point. Ito siya class, it is located at 2 and 0. So which means when x is 2, y is 0. So nandito si m sub 1, tama. And then sa m sub 2 naman, it is located at 0 to 6. Okay, when x is 0, y is 6. Nandito si m sub 2. And then sa m sub 3 is located at 2 and negative 2. So nandito si m sub 3. Okay. So using the formula for the center of mass x bar, we have, okay, si x bar magiging, ito pa rin yung formula na gagamitin ha. Tatlo lang yung masses dito, tsaka tatlo lang yung location because tatlo lang din yung given. Kung apat, apat din. Kung lima, lima din yung i-add nyo. So m sub 1 is 3 times, okay, 3 ha. And then 2 is yan yung x sub 1 natin. Tapos, plus si 2 na mass, okay, times x sub 2 is si 0. Ito yung x sub 2 natin, corresponding value of x sub 2 is 0. And then 5 is yan yung m sub 3 natin. And then x sub 3 is positive 2. Divided by 3 plus 2 plus 5, yung sum ng masses natin. That is equal to 16 over 10, which is 1.6 yung x bar. Sa y bar naman, sulat nyo lang, just copy their masses, and then replace lang natin si y sub 1. This is y sub 1 ha. Y sub 1, y sub 2, and y sub 3. So, ang y sub 1 natin this time is 0. Y sub 2 is, replace it by 6, and then y sub 3 is negative 2. So, we have y bar equals to 0.2. Consider a thin metal with the uniform density rho, RHO. Ang pagkabasa nito is rho, RHO, all throughout with its total mass, m sub t proportional to the area of the region. That is, total mass or m sub t equals to k times the area. Okay, suppose the metal piece is a rectangle with length L. Okay, ito yung length L niya. And width W. Since it has a uniform density, we can set a fixed value for density. Rho is equal to 1. Okay, so uniform yung density natin dito. Assume natin na uniform yung density natin, that is equal to 1. And its center of mass is at the center of the rectangle. Okay, ito yung center of mass ng rectangle natin. Thus, any plane figure of uniform density that can be subdivided into rectangular or circular regions is considered as a system of point masses in the plane. Take note that the center of mass of a rectangular region is at the center of the rectangle. Okay, take note of that ha. Yung center of mass ng rectangular region is at the center of the rectangle, assuming that the material is made up of uniform density. So, if may density natin class, kung sa arc, ang density ng arc S is rho is equal to m over L. That is, ang mass natin is magiging rho times L, where rho is equal to 1. Okay, so which means m is equal to L. Kung surface naman yung pinag-uusapan, m over A, this is area. Etong L na to is that is length of an arc. So, parehas pa rin. And then, kung solid naman, that is volume, di ba? Okay, kung surface, area. Kung solid, volume. Kung arc, L, length of an arc. So, P times, rho times V. For example, class, find the moment of inertia with respect to the y-axis and the center of mass of the plane region as shown in figure 5.7. Assume uniform density of rho is equal to 1. So, see for instance, ito yung given natin. And then, hahanapin natin yung center of mass nito. Given that uniform yung density nito, rho is equal to 1. So we may divide this or the region into two rectangles and assume that the mass of each rectangle to be concentrated at the center of each rectangle. Okay, so say for instance, hinati natin yung rectangle natin into 2 or we subdivide the rectangle into 2. So kung hatiin natin yan, ganito yung magiging form. Itong dash line na to, di ba? R sub 2 tapos ito yung R sub 1. So here, let A sub 1 is equal to the area of the rectangle 1. Hanapin natin yung area nito. And then, A sub 2 naman is the area of the rectangle R sub 2. So, ibig sabihin, iba yung area nito, iba din yung area ni rectangle 2. So, ang area ng rectangle class is equal to, area of the rectangle is A equals to the length times the width of the rectangle. So, ang length ng rectangle natin dito is dito, di ba? Sa R sub 1 muna tayo, that is 3. Bakit siya 3? Okay, bilangin natin yung distance. 1, 2, 3. Okay, so 1, start tayo dito kasi di ba ito yung endpoint? Ito yung isang endpoint. So we have 1, 2, 3. Yan yung L natin sa area 1 ng rectangle 1. Then yung width is from here up to here. So mag-count tayo. Kung ito yung endpoint, okay, let's say dito ha. Okay, so kung ito yung endpoint, sa ito nagpag-start mag-count. So, 1, 2. So, that's why ito equals to 2. So, 3 times 2, that is 6 square units with centroid at ang center nito class is, paano natin malalaman yung center niya? Negative 1/2 and 1. Okay, tingnan natin kung ano yung center nito. Okay, so here, we have dito yung center niya. Tapos, dito din is, nandito yung center niya. Kasi makikita din naman sa figure natin. Or, pwede ninyong gamitin yung formula ng center of mass. Okay, let's proceed to the area 2. Area of the rectangle 2. So, ang length ng rectangle natin is here. So, mag-count tayo. This is 1. Since ito yung endpoint, dito tayo mag-start. 1, 2, 3, 4. So, which means, ang length ng rectangle natin is 4. And then, yung width niya is starting here. Width ng rectangle. So, that is, dito tayo mag-start mag-count. 1, 2. So, that's why 2. So, 2 times 4 is 8. So, ang center of mass niya is, centroid niya is 2, 2. Okay. To find the moment of inertia with respect to the y-axis, the plane region in the figure in the previous slide may now be considered as the system of point of masses in the So, ang magiging mass ng area rectangle 1 is equal to 6 at negative 1/2 and 1. Tapos yung f sub 2 naman is 8 at 2 and 2. So, ito yung nakuha natin doon sa area ng rectangle. Using the formula 2 for x sub I and y sub I, we have yung x bar is, si m sub 1 is 6 times x sub 1 is 1/2, negative 1/2, and then m sub 2 is 8 times x sub 2 is 2. Tapos, 6 plus 8. And then sa y bar naman, we have m sub 1 is 6 times y sub 1 is 1. So, ito siya. And then, m sub 2 is 8. And then, y sub 2 is 2. Over 6 plus 8. So, 22 over 14. Yung y bar natin. Thus, the centroid is x bar, y bar equals to 13 over 14 and 11 over 7. For example, 5.5. Find the center of mass of the system of point masses. M sub 1 equals 2, M sub 2 is 4, M sub 3 equals 20, and M sub 4 equals 10, and M sub 5 is 30, are located in the x-axis at the points, okay, given siya, respectively. Ibig sabihin, sa M sub 1, it is located at x sub 1, negative 3, M sub 2 naman is located at x sub 2 equals negative 3, and then M sub 3 is located at x sub 3 equals to 4. M sub 4 equals, located at x sub 4 equals to 6, and then M sub 5 is located at x sub 5 equals 9. Suppose that we have a rod, neglect its weight, and place it on the x-axis. On the rod is a system of a finite number n is equal to 5 particles having the masses m sub 1 to m sub 5 located at x sub 1 to x sub 5. Okay, so in this figure, let's say for example, ito yung rod natin, nakalagay siya dito sa x-axis. Yung m sub 1 natin is located at negative 3. Yung m sub 2 is located at negative 2. M sub 3 is located at positive 4. Okay? Ito yung mga corresponding niya, ha? Corresponding location. And then m sub 4 naman is located at 6. M sub 5 is located at 30. Using the formula 1 for x bar, we have this. So m sub 1 is 2. Substitute lang natin si 2. And then m sub 2 is 4 times yung f sub 2 is negative 2. So we get x center of mass is at x bar equals to 6. So which means, ang hahanapin nyo lang dito na x as center of mass is yung x sa x-axis. For the last example class, find the centroid of the following systems of particles. Okay, so m sub 1 equals to 2 located at 3 and 1. Ibig sabihin x sub 1, x sub 2. Then m sub 2 naman, ang mass niya is 2. It is located at x sub 1, x sub 2 equals to 4. Then y sub 2 is equal to 1. Then m sub 3 naman is equal to 4, located at x sub 3 equals to 2, and y sub 3 is equal to negative 5. M sub 4 is equal to 6 yung mass niya. Located at x sub 4 is equal to negative 1, and y sub 4 equals to negative 4. So, ito siya. Ito yung sa f sub 1 natin. M sub 2 is here. M sub 3 is nandito siya, and then m sub 4. So, let us check this in the rectangular planes as shown in this figure, using the formula for x bar and y bar. So, using the x bar and y bar, ang x bar is m sub 1 is 2, and then x sub 1 is 3. Okay, lahat ng coordinates na nasa unahan, yan yung mga x's. X sub 1, x sub 2, x sub 3, tapos x sub 4. And then yung pangalawa naman, yan yung mga y sub 1, y sub 2, y sub 3, and y sub 4. So, substitute lang natin sa formula na to. So, we get x bar is 8 over 7 and y bar is negative 20 over 7. So that is for the center of mass of a plane region.